Alex Pierron.
So hi everyone, pleasure to meet you. So I'm Alex Pierron. I'm currently a first-year PhD student, and I'm studying cybersecurity impact of AI-based optimization techniques for B5G networks. I'm doing my PhD at Télécom Sud Paris at Institut Polytechnique de Paris in the Samovar Lab. And my PhD is also part of the POPR Future Network, but it's more for the administrative side note. So a quick personal background, my academic background at least. So I've done a double bachelor in math and physics at Paris-Saclay University. Then I've pursued with a master degree in mathematics and AI, which is both applied and fundamental coursework in mathematics at the Orsay Mathematics Institute. And then for the most interesting part, the PhD. So my PhD with the topic I've already explained to you, or at least said. And I'm supervised by Joaquin Garcia Alfaro, which is right here, raising the hand. Also with Jose Rubio Hernan, Michel Barbeau, and Luca Destico. So the keywords for the PhD are artificial intelligence. Maybe you have read it. Reinforcement learning, reconfigurable intelligent surfaces, B5G and 6G network, and cybersecurity. So this is for the quick presentation, but now what can I say about the topic itself? So a very quick overview. So I focus on operating reconfigurable intelligent surfaces with reinforcement learning for B5G and 6G networks, and enhancing their resistance to AI controller attacks. So it means that I'm focusing on making error models for risk more robust to adversarial attacks. And what is a risk? A risk is the thing you can see on the left. It's, I would say, an intelligent mirror, if I have to simplify it, which can redirect the signal by adjusting the amplitude and the phases of the set signals to the final users. It can go both ways. And so it helps for future B5G and 6G use cases. And for reinforcement learning, I've used a nice scheme about the general framework of it. I'm not going into details, but you are interacting with an environment, with your agent, which is the AI model. You take action, and then based on this simple retrospective loop, you get a better system, so on and so forth, by playing with the reward and also the general learning algorithm. So this is the general overview, or at least the general vision. And why are we using RISE for B5G or 6G networks? For desirable properties, such as the fact that it's passive, so it consumes less energy. It's easy to deploy, far more easier than base station, which is costly. And also we can address the problems of obstacles and so on. So better, I would say, figure is this one. Maybe a bit too much writing, or I don't know, maybe. Do you see correctly from everywhere? So we have the signal that is going from the base station, replicated by the RISE, going to the final users, which is, I would say, everyone. And we want to address the case where we have some attackers or eavesdroppers that are perturbating this signal, and the consideration for the AI system that is operating the RISE right here. So this is the general framework that we are addressing, the general problem, and then we have many sub-tasks to address. So among them, these are the current research axes I'm working on. So first thing first, develop an efficient and open source environment for the experiments, because there is none that is available and that is, I would say, good enough for what we want to do. And then demonstrate new successful attack methods targeting the AI controller, not the cybersecurity protocols or so on. We want attacks directed to the AI controller. And then once we will have this proof of attack, we want to enhance the reinforcement learning model capabilities to handle these attacks, and also the capability of the system to distribute correctly the signals among all the users, because at the end, you want to receive your images or whatever you want on your phone. So a final objective is to use and provide specific tools to address this issue. So this will be my research for, I guess, the 2 to 3 next years. So if you have any question, feel free to reach out to me now or after during the poster session. Thank you.